10.2, Introduction to Conics, and then focusing on parabolas. We're going to recognize a conic as the intersection of a plane and a double napped cone. Write equations of parabolas in standard form, and then use a reflective property of parabolas to write equations of tangent lines. So conics. A conic section, or simply conic, is the intersection of a plane and a double napped cone. Notice in figure 10.7 that in the formation of the four basic conics, the intersecting plane does not pass through the vertex of the cone. So look at these examples here. So the circle, it goes in this direction here, parallel to the base, and then here it's angled for an ellipse. For a parabola, notice that it's only that piece of it here, and then a hyperbola intersects both of the top and the bottom. Now, when the plane does pass through the vertex, the resulting figure is a degenerate conic. So looking at these examples here, so we notice that if it passes through the vertex here, it's a single point. Then if it's right here on both sides, it's a line, and then two intersecting lines here if it's going to the sides of the conic. There are several ways to approach the study of conics. You could begin by defining conics in terms of the intersections of planes and cones, as the Greeks did, or you can define them algebraically in terms of the general second-degree equation. So we're looking at the equation ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. However, you will study a third approach in which each of the conics is defined as a locus, collection of points satisfying a given geometric property. For example, in section 1.2, you saw how the definition of a circle as a collection of all points x, y that are equidistant from a fixed point hk led to the standard form of the equation of a circle. Well, then recall that the center of a circle is at hk and that the radius of the circle is r. So in section 2.1, you learned that the graph of the quadratic function f of x equals ax squared plus bx plus c is a parabola that opens upward or downward. The definition of a parabola below is more general in the sense that it is independent of the orientation of the parabola. So here's the definition of a parabola. A parabola is a set of all points x, y in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus, that's not on the line. The vertex is the midpoint between the focus and the directrix. The axis of the parabola, or the axis of symmetry, is a line that passes through the focus and the vertex, and it's also perpendicular to the directrix. Note in the figure above that a parabola is symmetric with respect to its axis. The definition of a parabola can be used to derive the standard form of the equation of a parabola with vertex at hk and directrix parallel to the x-axis or to the y-axis stated below. So here's the standard form of a parabola. The standard form of the equation of a parabola with vertex at hk looks like this. So it's a little different than maybe you learned last year, but that's okay. So x minus h squared equals 4p times 4p y minus k, and p can't be 0. And then y minus k squared equals 4p times x minus h, where p is also not 0. Sorry, there's an extra parentheses here, which shouldn't be there. So just ignore that extra parentheses. Okay, and then notice that for the horizontal or the vertical axis, the directrix is y equals k minus p. So vertical axis, we're using this. Notice that x minus h, the x is squared, and then for here the y is squared for horizontal axis. Okay, and we'll look at some pictures below to help us out. The focus lies on the axis p units, its directed distance, from the vertex. If the vertex is at the origin, then the equation takes one of two forms. So x squared equals 4py for the vertical axis, and y squared equals 4px for the horizontal axis. So let's kind of take a look at some pictures to help us out with this, to review a little bit more. So when we have a vertical axis, it's going this direction. Notice that the focus is here, h comma k plus p. So that should make sense. It's shifted up or down. Then the directrix is k minus p on the other side. The vertex is right in the center. So therefore, if the focus is 2 units away from the vertex, then the directrix is also 2 units away on the other side. So again, the vertex is right in the center, so you could find it. And then, so this is when p is greater than 0, it opens up. If p is less than 0, it opens down. More than anything, it's knowing what the equation looks like. So this is x minus h to the squared equals 4p times y minus k. It is similar to the equation we used before, and if you remember, y equals 1 over 4 times p, right? So we could divide by 4 minus p, and then you could rewrite the equation. So that was, maybe from previously, and so it's good to kind of look at that. But we do want to look at this new form here. Then if it's horizontal, so it's turned to its side, notice that the y is squared. And so if it's open to the right, you see it here. The h is, the focus is in the inside, always in the interior. Directrix is on the other side. Notice that the y is squared, and then it's 4p times the x minus h, okay, for both. So hopefully that helps you out just as a general information for conics as well as the standard equation of a parabola.